Okay, now we're going to shift our attention and do problems which involve finding the scaling factor. So let's begin by doing example 2. Under a dilation centered at the origin, triangle A, B, C becomes triangle A prime, B prime, C prime, and they give us the coordinate of each. So now we have to decide what is the scale factor for this dilation. So the first thing I'm going to do is I'm going to arrange my coordinates here. So here I have A, which is 0, 0. I have B, that one is 0, 4. And I also have C, which is, they're telling me it's 6, 0. I'll do the same thing for A prime, B prime, C prime. Let's do that in orange. So we get A prime, that's going to be 0, 4. Well, it looks, well, whatever. B prime is 0, 10. Sorry, A prime is 0, 0. C prime is going to be 15, 0. In order to find the scaling factor, I'm going to need to set up an equation. So here's the strategy. So I know that if I get one of these values and multiply it by a scaling factor, let's call it D here, D for dilation. If we multiply it by a scaling factor, we're going to get the outcome of this value. So here's what we can do. Let's say we get this value of 0. And here, let me underline it. If we multiply this value of 0 times D, we should get this value right here. However, this is not going to help us because 0 times whatever is still going to give us 0. So that gives us no clue on getting the dilation. So we're going to have to pick a better value. So let's pick this one instead. So if we get 4 and we multiply it by D, we should get 10. So let's set up that equation. So we're going to get 4 times D. And let me switch to purple if I'm able to. So 4D equals 10. And that's going to allow us to solve for the dilation. Now we can do this only if this is centered at the origin, which in this class, that's always going to be the case. So now we can split this equation and solve for D. So I'm going to do the inverse operation. The inverse of multiplication is division. So I'm going to divide both sides by 4. Here, 4 divided by 4 is just 1. So we get 1 times D. And then that's going to give us 10 over 4. And then here, I'll allow you guys to use the decimals. So here, we're going to get 2.5. So here, let me just write it, 2.5. So we get that the dilation D, let's switch back to purple, that's going to equal 2.5. And if you, well, something I encourage you to do is to reduce the ratio just for extra practice. So here 10 over 4 is the same thing as 5/2. So that's how you would find the dilation or the scaling factor for these kinds of problems. Let's touch another variation of these examples. This time we're going to get a picture. So here, example 3. The figure shows a dilation of ABC to A prime, B prime, C prime. The center of dilation is at the origin. Is the dilation an enlargement or is it a reduction? Well, we know that the original figure is this pink one because the pink triangle is the one that's labeled ABC. The one with the primes is the blue one, the bigger one. So we can say that the pink one is getting scaled into the blue one. So since our original figure is smaller, here we have an enlargement. Okay, the dilation we're using is making the figure a lot bigger. Now we have to find that scale factor. And here's one way to do it. You can get the coordinates of A, B, and C, which are listed right here, and then get the coordinates of A prime, B prime, C prime, which are right here. Now this problem is the same as this one we just did right here. So I'm going to use A and A prime. So here, let me just write these separately. So I'm going to get A, negative 2, 2. And then we know that this goes through a dilation. and a prime becomes -4, -4. Oh, I put 2 of these. Okay, -4, -4. So now in order to set up my equation, you know that a dilation is going on here, dilation D. So it doesn't matter which value of the 2 we get, so I'm just gonna stay consistent and get the first one. So if I grab this value and multiply it by a dilation D, it should spit out this first value. Likewise, if I get the second value and multiply it by the dilation D, I should spit out this second value. It just turns out that here it's oh no, it is a little bit different. Well, let's calculate the first one, the one I mapped out in red. So we're gonna have, whoa, we're gonna have -2 times D. That's gonna equal -4. And now we gotta solve this equation. So let's split it in half. Okay, so here I'm gonna divide by -2. I divide by -2, and then -2 divided by -2 is gonna give us 1D. And then negative divided by negative is positive. 4 divided by 2 is 2. So here we have a scaling factor of 2. All right, so finish the assignment and I'll see you on the next lesson.